Good morning, class. Happy Wednesday. So we're continuing on our topic of volume, okay? Remember yesterday we reminded ourselves of the formula and we figured out what to do if we're missing different dimensions and we have a volume. So now what we're going to be doing is we're going to be looking at things that might be liquid, okay? And we're going to remind ourselves how that works. So here I have my little 1 centimeter cubed cube, right? So if we were to take this and make a watertight container exactly this size and filled it with water, this would be worth 1 milliliter, okay? This cubic centimeter, 1 centimeter cubed equals 1 milliliter, okay? So I want you to write that down in your notebook. You can write the date if you want to, or you can just continue under from yesterday, but I want you to write this out and circle it because this is important, okay? So 1 milliliter equals 1 centimeter cubed, okay? So like this is worth, if it was a liquid, it would be worth 1 milliliter, okay? So that means that if we had this cube and we filled it with water completely, what would we get? So let's use our formula. We know that volume equals length times width times height, which equals 4 times 3 times 5, okay? And that equals 60 centimeters cubed, okay? And because we know that 1 milliliter is the same as 1 centimeter cubed, that means that if this was full of water, it would be worth 60 milliliters, okay? So do you see how that works? So we can take our cubic centimeters and convert them directly into milliliters, okay? So now, what if we have this? So this is my base 10 cube, and it's 10 by 10, okay? And we know from our cubing perfect cubes, if each side is worth 10, then this cube is worth 1,000 centimeters cubed, okay? So 10 times 10 times 10 equals 1,000. So this is worth 1,000 centimeters cubed. So what is this worth in milliliters then? This 1,000 centimeters cubed. Well, it is worth 1,000 milliliters, right? Because we have the conversion and it's direct, okay? But what do we know 1,000 milliliters is? 1,000 milliliters is worth 1 liter, okay? So this, if this was made of water, if it was a watertight water container, it would have 1 liter of water in it, okay? So our 1,000 centimeters cubed equals 1 liter, okay? And you have that here on your anchor chart, okay? 1 liter is 1,000 centimeters cubed, okay? So now that we have this information, and I want you to write this down too, that 1,000 centimeters cubed equals 1 liter. So you can write this whole thing, or you can just write that it equals 1 liter. And circle it too because it's also important. So now that we know this, we can use it to help us understand volume. So it is important to note that 1,000 centimeters cubed does not equal 1 meter. Even though we know that there's 100 centimeters in a meter, it doesn't convert the same way because those are linear units instead of cubic units, okay? So, but liters and milliliters are three-dimensional units, okay? And so that's how they are converted in the same way. So 1,000 centimeters cubed does not equal 1 meter cubed, okay? That's important to note, but it does equal 1 liter, okay? And so we're gonna be working on that idea together now to look at shapes and find the volume that we need to. So now we're going to use that to find dimensions using liters and milliliters as our volume, okay? So we have here our container of liquid, okay? So we know that if this container was full, we could just do 10 times 20 times 12 to find 2,400 centimeters cubed, which would equal 2,400 milliliters or 2.4 liters, right? Because that's our conversion. But what if the water is only this high, okay? And what if the value of this water is 1 liter and 600 milliliters? How do we figure out the height of the water in the container? So we're looking for this now. Okay? And what we can do is we can use our volume, right? It's the same as we learned yesterday. If we have the volume and we're missing the height, we use this formula, okay? So what we're gonna do, and the only difference is that now our units are in liters and milliliters, okay? And so what we're gonna do, because we know that we have 1,000 centimeters cubed in a liter and 1 milliliter equals 1 centimeters cubed, I'm gonna put this into milliliters. So I'm gonna do 1,600 over 20 times 10. And we know that 20 times 10 equals 200. Okay? And what we can do, because now we have to divide 1,600 by 200, and we know that because this is a fraction, we can simplify it, and we can knock off our zeros, okay? Because there's 2 zeros on the bottom and 2 zeros on the top. So I'm gonna cross out the zeros, and then we just have 16 over 2, which is gonna give us 8, okay? And the 8, of course, is 8 centimeters, because that is the value of the height, okay? So do you see how that works? So we use our volume in the form of milliliters to find the missing dimension, which we're still going to show in its unit, which is centimeters, okay? So let's look at that together in the textbook with question number 4, okay? So question number 4 says a rectangular container 20 centimeters long and 10 centimeters wide contains 2.5 liters of water. Find the height of the water level in the container, knowing that 1 liter equals 1,000 centimeters cubed. So we're doing the same thing as we did last time, and we even get to use this shape again because we have 20 by 10 here, and they've shown us the steps that we need to take. So if the volume of the water is 2.5 liters, we can multiply that by 1,000, because that's how we convert between this, to equal 2,500 centimeters cubed, or milliliters, okay? And so now that we have this value, we can do 2,500 divided by the length and the width. So 20 and 10, which we know again is 200. Okay, and we'll cross off our zeros for ourselves again, and we have 25 divided by 2, okay? And 25 divided by 2 is 12.5. So make sure you are showing your answer in a decimal, because it would be 12 remainder 1. And then our units are centimeters again, okay? So the height is 12.5 centimeters, okay? And that is it for our lesson today. So now it's your turn to practice using volume as liters and milliliters and finding the dimensions. So it's the rest of exercise 53. So this is page 98 now, and it's 2 questions that use milliliters and liters as your volume, and you're still following the same process to find the unknown dimension. So again, make sure that you're looking at your anchor charts to help remind you of how things work. And otherwise, if you have any questions, you can reach out to me. And that is math for today.